Alright guys, so as I mentioned, I'm going to show you a video on some things we can do with piecewise functions. So here, this is how to evaluate a piecewise function. So we can see up top, we have two piecewise functions. We have f of x, which is defined as negative 2x plus 4, whenever x is less than or equal to negative 5. 3x minus 8, whenever x is between negative 5 and 2. And 5, whenever x is greater than 2. Okay. Over here we have g of x, which is a constant function, is equal to negative 2 when x is less than 4. And 6 when x is greater than or equal to 4. So what we're going to do is we're going to evaluate these functions at different values for x. So here, f of negative 10, what this means is, what is the value of this function, f, when x is negative 10? So if I look here, I have to figure out which interval negative 10 is on. So here, if I take a look, negative 10 is less than or equal to negative 5. So I know it's on this interval, so I'm going to start by looking at this function. So I'm going to do this equals negative 2 times negative 10 plus 4. So I end up with 20 plus 4, which is 24. So f of negative 10 is equal to 24. All right. Now 0. If we take a look here, 0 is in this second interval from negative 5 to 2. So that means I'm going to go ahead and take a look right here. All right. So f of 0, I'm going to use this middle part here. So I'm going to do 3 times 0 minus 8, which is negative 8. So f of 0 for this function is negative 8. Now 2. 2 is at my boundary, right? So here we can see that the function switches at 2, but only one of them includes 2. So I'm still going to use this middle part of the function because this one says less than or equal to 2. So 2 would fall in this range. So I'm still going to go ahead and say here, this is going to be 3 times 2 minus 8. Which is negative 2. So f of 2 is equal to negative 2. Now this last one here, 6. 6 is clearly greater than 2, so I'm going to go ahead and take a look at this part. And this is a constant function. So f of 6 is simply 5. All right, there's no variable input. It's just no matter what I put in, if it's greater than 2, I get 5 out. Okay. Now we do something similar over here, right? G of negative 1. Negative 1 is less than 4. So this equals negative 2. 4. Well, 4 is not less than 4, but 4 is greater than or equal to 4. So f of 4 equals 6. And then g of 126. Well, 126 is clearly greater than or equal to 4. So that's also going to be 6. Okay. So that's how we evaluate a piecewise function. Is first we identify what the input is. Once we know the input, we look for which interval it's on. Once we know the interval, we use the corresponding expression to the left. Okay. So pretty straightforward. The next skill we want to be able to have is knowing the equation of a piecewise function by looking at a graph. Okay. So what I'm going to do here is I'm going to go ahead and say that this is scaled by 2's, right? So this is 2, this is 4, this is 6, so forth and so on, right? Same thing going down. This will be negative 2, negative 4, negative 6, right? So each of these blocks goes by 2, just to make it more interesting, okay? Now we can see here, if we go ahead and look at this graph, there's already some clear divisions here, right? So I can see there's clearly a division right here along this line, right? And there's clearly another break right here along this line. So there are 3 clear, distinct parts to my graph, okay? So I know when I go to write f of x, it's going to be f of x equals, and there's going to be 3 parts. Now I can go ahead and write the intervals, right? I can see this first interval here is defined up to negative 4. So anytime x is less than negative 4, I'm going to be looking at this equation right here, or that line. So this part's going to be x is less than negative 4. Now this closed circle here tells me that this line is included, so I'm going to put less than or equal to negative 4. Now this one picks up here at negative 4 and goes to positive 2. So here I can put negative 4 is strictly less than x is less than 2. Now again, I have a closed circle on this middle part here, so I can see that that's going to be less than or equal to 2. And then finally my third interval is for x values greater than 2, clearly not including 2. So it's going to be x is greater than 2. Okay? Now what we need to do is we need to determine the equations of these lines. All right, and you can do them in any order, right? So for example, I can see this one is just a constant function. It's not moving. So I know on this third interval that if I pick an x value that's greater than 2, this function will always equal -4. So that one's pretty easy, right? Now this one over here might be a little bit more challenging, right? We can go ahead and figure out the slope, right? We can see that if I go up 2, I'm going over 4, right? So my slope is going to equal 2 over 4, better known as 1/2. Now this line doesn't touch the y-axis, but we have to pretend it keeps going. And if it were to keep going, where would it cross? And I can see it would cross here at -2. So my y-intercept will be b equals -2. So now I can write this equation, y equals mx plus b. It'll be 1/2 x minus 2. And that's for my first interval where x is less than or equal to -4. And again, you can do these in any order you want. You just have to be consistent, okay? So like here, if I want to talk about this one first, I know that goes with my third interval. If I want to talk about this one second, that one goes with my first interval. And then here, even if I wanted to do this one first, that's fine. But it would have to go with my middle interval, okay? Now this one's a little bit easier, right? I can see I go down 2 over 2, so -2, 2. So I can see my slope is -1. Right? And here I can actually see where it crosses the y-axis, which is at 4. So b equals 4. So I can write my equation as -x plus 4. And there, I've now found the equation of this piecewise function. Okay? Now what you're going to see is it's always going to be line segments when you're doing these problems, particularly for the homework where you have to do some matching. Okay? So here, just so you can also go back over this skill, let's say I wasn't too clear on where this part crossed the y-axis. Maybe I'm like, well, maybe it's -2, maybe it's not. That's fine. Pick 2 good points, right? Here's a point, here's a point, right? If I get the coordinates, it's -2, -4, -6, -8, -2, -4, -6. So I've got the point -8, -6, okay? If I go ahead and take a look at this point, we've got -10, -12, 2, 4, 6, 8, -8. So -12, -8. Okay? I can find the slope doing my basic slope formula. Okay? I go ahead and do -6 minus -8, right? Y minus y, over, since I started with -6 up top, I have to start with -8 on the bottom. Okay? And watch what happens here. Plus a positive. So I end up with 2 over 4, which is 1/2. So you see I get the exact same slope if I use the ordered pairs, right? Now to find the y-intercept, I know the slope, I know one of the points, I can go to my equation, right? So here I'll go ahead and say, well, y equals mx plus b, and I want to solve for b. If I want to solve for b, I have to plug in for y, m, and x, okay? So here, just use this point. Y equals -6, m we just found is 1/2, and x is -8 when y is -6. Well, half of -8 is -4. Add 4 to each side, and you get -2 equals b. Again, this is the same thing we got over here. So we just verified b, we just verified m. We know that our equation 1/2 x minus 2 is correct. All right, again, these are all skills that you guys picked up in Algebra 1. You practiced again in geometry, and then you definitely saw in Algebra 2. All right, go ahead and don't worry about the classwork assignment. You're welcome to work on that with a friend. What I want you to do is work on the homework assignment. Okay, it's going to be promised just like this. Email me early and often if you have questions.